Hello, and my name is Ashish. Welcome to my Learning Rust programming series. Today, we are going to explore casting, difference between suffixed and suffixed literals. Then, we'll look at type inference engine and aliasing. First, let's look at casting among variable. Rust provides no implicit type conversion between primitive types, but explicit type conversion, that is casting, can be performed using the as keyword. Let's take an example. So I have decimal number, which is float 32, and I have integer. Now, if I try to assign directly this decimal number to this integer, then I'm going to get compile time error. But so what is the solution then? I have to use explicit type conversion. So this is implicit type conversion, which is supported by many languages. So let me comment this, and now what we'll do is we'll have integer u8, and now I will use as keyword. So this is explicit type conversion. So explicit type conversion is allowed between compatible types. So for example, I cannot do explicit type conversion between string to integer, etc. So only compatible types can be converted using explicit type. Now let's talk about literals. So in Rust, we have suffixed and unsuffixed literals. Let's take an example. Let x equal to. So this is suffix literal. Opposite to that, if I declare something like this, let I equal to 1. So in this case, the type is this is called as unsuffixed literal, as their type depend on how they are used. So here you can see I32 is automatically assumed by compiler. So this is about. So let's add few more suffixed few more suffixed. Sorry for spelling mistake. Yeah. So let's add few more suffix literals. So I will add 32-byte unsigned integer. Then let's add 32-byte float. And in suffix, let's add one more value, that is float. Okay. Now, what we are going to do is let's try to print the size. So here we are going to use size of value function from memory crate. So for now, let's use it like this: std mem size of val, and let's pass reference to the variable and add semicolon. So I will add same for the y, then for z, then for I, then for f, and let's run this program. Yeah, so you can see the size of I. So for suffix, it was pretty clear at the compile time itself. X is of unsigned integer of size 8-bit, so it's printing 1. Then we have y as u32, that is 32-byte, so 32-bit, so that is 4-byte. Then for float f32, same size, that is 4-byte. And here for unsuffixed literals, we are seeing it has automatically taken as 32-bit integer, so 4 bytes, and for float, it has taken unsigned 64-bit. Unsigned 64-bit, that is 8-byte. So yeah, so we have passed this value to the println function. So next is we are going to check type inference engine. So type inference engine is very smart engine which does more than looking at the type of the value expression during an initialization. It also look at how the variable is used afterwards to infer its type. Let's take an example. So let me take one element. So we are going to use one built-in data structure, that is vector. So I'm just creating new instance. Vector is like growable array, and I'm not here setting up its explicit data type. So what I'm assuming that when I try to add element using push function, I'm trying to add element type. Okay, what our inference type inference engine is going to do is automatically assign the type of vector to whatever element I'm trying to insert it for the first time. So I'm going to add one println function, which is going to simply add. It is going to so this colon and question mark prints debug information about the value you pass. So these are some format for standard format traits that we are going to discuss in next video. So for now, let's assume that this is going to print debug information about the variable you are going to pass. So if I run this, then you will see it's printing whatever contents you have in this vector, and it automatically set type as type of vector as unsigned 8-bit integer. So if I comment this push function and then if we run this, so actually I'm getting compile time error as we need to give explicit type. So this is how we have to add explicit vector data type. Then the compiler is not complaining. So this is again just like suffixed and unsuffixed literals. Just like that, we have to specify here its data type at the compile time, and if we don't specify, then it will rely on the action, whatever action we perform, and on that vector, on that type, automatically the inference engine will assign that data type to that vector. The next up is aliasing. The type statement can be used to give a new name to an existing type. So type must have upper camel case names, and compiler will raise a warning. Exception to these rules are primitive types like usize, f32, etc. So there are some exceptions where you cannot use primitive types. Usize is unsigned integer where architecture size depends on architecture, and f32 is like float 32-bit type. So let's take example what exactly is type. This is how I can define the type. So type keyword, and okay. And if I want to use this, then let nano. I'm going to use directly. So let's print it. So I have to use upper camel case notation. All right. So it is still complaining. Okay. So here we are supposed to take snake case, and same variable I'm supposed to take here. All right. So you can see 5 nanoseconds, 2 inches, 7 units. It has printed. So this is how you can use aliasing. So this is the main use of aliases is to reduce boilerplate code. So thanks for watching my video. In next video, we are going to see standard display formatter threads. Those are available in Rust. Thank you.